let's break down the list of components that we will be using. First is the breadboard, and for power, we'll use 9-volt battery. We also have 7486 IC, which is an XOR gate, and 7432 IC, which is an OR gate. We're also using an LED which will light up to show us the output of our circuits. To protect our LED and control the current, we'll be using 220 resistors. Next up are the 3 switches. They'll allow us to control the inputs to the logic gates. And finally, we have 2 sets of jumping wires. We'll use the small and medium sized wires to connect everything on the breadboard.
The circuit has 3 inputs A, B, and C. First inputs A and B are connected to the first XOR gate. This gate outputs high if A and B are different, and low if they are the same. Second, inputs B and C are connected to the second XOR gate. This gate outputs high if B and C are different, and low if they are the same. Third, the outputs from both XOR gates are then connected to an OR gate. The OR gate outputs high if either or both of the XOR gates output high, and low only if both XOR outputs are low. And lastly, the outputs from the both OR gate then controls the RGB LED, lighting it up when the OR gate output is high.
For this schematic diagram, first place the buttons on the left side. We have 3 buttons, A, B, and C. And each button has its own resistors. And next one is place the ICs to the middle part of the breadboard. Place the first one on the left side, which is the 7486 or the XOR gate, and the other one is the 7432, which is the OR gate. Meanwhile, on the right side, place the LED there and make sure the cathode part or the short one is connected to the negative rail. For the jumping wires, connect all the inputs to the positive rail, and as well as the pin 14 for every IC. Once it was all connected, place the resistors to the negative part, and as well as the pin 7 of every IC. To make it work, place a jumping wire on the input A going to the pin 1 of the XOR gate, which is the 7486 IC. Another jumping wire for input B going to the pin 2 of the same XOR gate. To show its output, connect a jumping wire on the pin 3 of the XOR gate going to the pin 1 of the OR gate. Another set of combination for XOR gate is input B and input C. Connect a jumping wire from input B going to the pin 13 of the XOR gate IC, and another one for input C going to pin 12 of the same IC. To show its output, place a jumping wire on pin 11 going to the pin 2 of the OR gate. So next jumping wire will be placed on pin 3 of the OR gate going to the anode part of the LED. And that should be it for this schematic diagram.
We'll go through the truth table for the XOR and OR gates along with the combination circuit we're working on. Let's break it down. First, let's start with the XOR gate or exclusive OR gate. The XOR gate output A1 only if the inputs are different. Here's how the truth table looks. When both A and B are 0, the output is 0. If A is 0 and B is 1, the output is 1. If A is 1 and B is 0, the output is also 1. Finally, if both A and B are 1, the output is 0. Now, let's move on to the OR gate. The OR gate outputs a 1 if at least one of the inputs is 1. Here it's the truth table. When both inputs A and B are 0, the output is 0. When A is 0 and B is 1, the output is 1. When A is 1 and B is 0, the output is 1. And when both A and B are 1, the output is still 1.